Hello everyone, welcome back to the another session in design and analysis of algorithms. The topic name is tries. This topic you'll find in 4th unit as 6th topic. So basically we know the tree data structure. So this is not tree, this is trie. Both are data structures, and this video will help you out to know the differences in between the tree what we know and the trie what the subject talks about. Now let's get started. So basically trie is a data structure. Now the data structure what we know, that's our searching trees. We were heard about many trees, right? Binary search tree, and you have the other trees also. All these trees, whatever you heard, all these data structure trees are used to store the collection of numerical values, but they are not suitable for storing the collection of words or strings. Now, the trees what we were already aware in the data structure subject, all the trees are to store numerical values, but there is no data structure which is suitable among the data structures what we were studied earlier semesters that are not suitable to store words or strings. So we need a data structure which is trie. Trie basically came from retrieval word, this trie I am talking. Now trie is a data structure used to store the collection of strings and makes searching of a pattern is words more easy. So trie is a data structure where we'll store the words and the strings as a node, and also it will help us to search the patterns more easily. And trie data structure makes retrieval of a string from the collection of strings more easily. Trie is also called as prefix tree and digital tree. It is an efficient information storage and retrieval data structure. And we'll see some examples to understand more better the tries. So from the previous slides, you got 3 points to understand what exactly trie. We'll store all the words or the strings, and we'll search the string or word in this tree. So this is what the key points what we were heard about. Now let's understand the categories of tries. Those are 3 categories in tries. The one is standard tries, compressed tries, suffix tries. As far as this video is concerned, we'll be going to talk about the standard tries. Now a trie searches a string using some pattern or using some keyword. It takes big O of m time complexity, where m is the length of the string and the space complexity is big O of n, the number of characters what it is having in a word, that it is what space complexity, and the time complexity is big O of m. And the second is in trie, if it is standard or compress or suffix or whichever trie it is, in trie every node, while you are constructing the tree, every node except the root stores a character value. That means root will not store any sort of characters. So you cannot store anything in the root position. So every node other than this root will have a character value. And every node in trie can have one or more number of children. All the children of a node are alphabetically ordered. If any 2 strings have a common prefix, then they will have the same ancestors. Now we'll see the example to understand in better way. So before I discuss the example, I wanted to give you some properties to understand. Let's talk about the properties. The first property is the root node of the trie always represents the null node. That means no root node of any category should have a value. So these are what? Null nodes, dummy nodes. And the second property, each child node is sorted alphabetically or alphabetical order. The third property, each node can have a maximum of 26 children, because I told you that these are all alphabetically ordered, so there are only maximum of 26 possible of child nodes. The fourth property, each node can store one letter of the alphabet except the root. Only one alphabet can store one letter of the alphabet. Now, keep in mind these all properties. Now we'll go with the example. Now let's see this example. Standard tries. So the example is what? S is equal to strings, set of strings is equal to beer, bell, big, bug, stop, stock. So root node should not have any of the character, so it is a null node or it is a dummy node. Now what is the first word? Bear. So first word, how we will be constructing this is, each node in the tree except of root node should have single alphabet, one alphabet. So this bear will start with a letter of B. So let's generate a children node under this root with B. Now, so after this B, what is the next alphabet to search this? B, E. So B, E. Next is B, E, A, R. So I constructed B, E, A, R, bear. Now to construct this bell, already B is available here. So we will not extract the other node. We will not do it. We will be going to find out the branch, or we will be going to extract the other branch as it is takes a second one. That means B is same. In bear, B and bell, B is same. That means we will come to up to B. Now if we go to this end, it will be a BEAR bear. If we'll come to this to enhance the node, that is bell. So after you construct bell, next is big. In big only B is the common, so B is available here. That is what? E, the word which starts with E. I mean second letter is E. So second letter of this big is what? I. So that means I have to take the other path. That means BI. So later it is G. Okay. Now, and the next is what? The word bug. Even in the bug, B is the first alphabet. So this is right. And U I don't have, so I'm generating the U and G. Now let's see. So this is what start with the character of S. But I have a branch which starts with the B. So let's generate the other node with the S. Now in S, STOP. Here it is stock. In stock, ST are common. So let it be ST here. And from O, you will take the turn that C and K. So this is what actually standard trie, the way of constructing the words as your tree. Now, in the coming videos, we'll see the problem with the standard tree, and also we will discuss about the other trees.